Hi guys. So it looks like I do have to be home today and tomorrow. I'm hoping to be back Tuesday. But I thought what I would do then is just give you your lesson through, well, recorded live, I guess. But I still wanted to give you some sort of a live lesson rather than having you try to get them on your own. So I am doing this from home this morning, and I do want to show you this. Come here. Come here. I'm going to show you my math buddies today, though. Brooklyn. And Dixie? Daisy, Dixie? Daisy? Oh, there she is. So at least I do get some joy of it getting to be with them, even if I can't be at school with you guys. So, all right, so what I'm going to do is put this um, screen down, put that away, and then I'm going to start with the notes. Now, I had this prepared already for some interaction in class, so you guys are kind of lucky that you're not going to have to do that. But I'll kind of like act like what I would have wanted you to do in class. Okay, so the three things that we need to learn here in 2.2, sorry about that, in 2.2 is we need to know the vertical asymptote formula, and it is a limit formula. Same thing with horizontal asymptotes, and then also the end behaviors. And so what we'll do is we'll go through this, and then there's some practice questions in the book that I want you to try. And then we'll kind of see time-wise how that will work, but you will be turning those questions in. Anyway, so we'll start from here. All right, so the first thing I want you to look at is something that we know already, like this function 1 over x, it's graphed over here on the right, and we know that this function has a asymptote. It actually has two asymptotes. It has one at y equals 0 and one at x equals 0. So let's just look at some ways that my limits can be asked now. So what if I ask for the limit of this function as x approaches 0 from the right? So now here's my 0 and I'm approaching from the right. And what you're going to notice, oh, that's a really weird one there. What you're going to notice is that those numbers continue to get smaller and smaller and smaller, but in the positive direction. And so what we're going to call that is actually positive infinity. So there's no way to close that off. And so now we're in this other realm of having limit questions that either approach infinity. She's trying to answer. That either approach infinity or that can have an answer of infinity. Okay, so just kind of getting an idea of what those might look like. All right, so the next one, what about from 0 from the left? So now this is going to going down as we approach 0, which is going to be a negative infinity. Now we know from the previous section that this third question here, then what do we say about the limit as x approaches 0 then? Well, if from the right is positive infinity and from the left is negative infinity, and those are two different answers, then my answer would be, scream it out if you know it. Yes, very good. This is fun. I'm acting like I'm actually in class. It would be a does not exist. Okay, and that's because they're not the same on each side. All right, so then we could also have these new questions that say, well, what happens as x approaches infinity? So as my x values here approach infinity this way, then what happens to my y values? Well, we already know that there's an asymptote here at y equals 0. So as these numbers on the x-axis get larger and larger and larger, my y value just gets smaller and smaller and smaller and smaller, but it's not really doing anything but getting closer and closer and closer to 0. It never will be 0, but it's getting closer and closer to 0. So this answer would be 0. And then the same thing as x approaches negative infinity. So now I'm looking at these x values. As x approaches negative infinity, I'm also going to get to 0 because my y values are going to get smaller and smaller and smaller and smaller, but they're never going to be 0. Okay, they're getting close to 0, but they never will be 0. Okay. All right, so that's just kind of an idea of now I can ask you, instead of at x values, I can ask you for infinity and negative infinity as well. Okay, so now that leads us into the talk that we're really trying to get here today. So what I was going to have you do was draw a function, any function you want to, that has a vertical asymptote. So on your whiteboards, draw out your vertical asymptote. So you would just create any function. It doesn't matter what it is. So I'll just put my vertical asymptote right here. And then I'll make my function. Sorry, the dogs are playing behind me. I'm sure you can hear them snorting. So then we have some vertical asymptote, whatever. And so what we're looking for is, and actually let's just do one side of this instead of the other side. So we have some function that's getting closer and closer. Make that a little bit nicer. Closer and closer, and it's going to hit that vertical asymptote and never actually touch it. So can you derive the limit definition, sorry, for a vertical asymptote? Well, let's see. So we're going to start with the limit. So the limit, and I want you to derive it so it helps you to memorize it or to know it. So let's see. So we're going to do the limit as x approaches, and we'll just call this some number. Now, if it were up to me, I would use J for Jeff, but I'm going to use I think they use in the book, they use B. So we'll just use B. And we'll say, okay, well, if I approach some number, and it could be a positive B or a negative B, doesn't matter, positive or a negative B, of some function, then what should my answer be? Okay, so think about that for a second. As I approach B from the left or right, doesn't matter, positive or negative B, doesn't matter, of that function, I should, if I have a vertical asymptote there, I'm either going to go to positive infinity or negative infinity. And so what you want to be able to recognize is this definition. So your AP Calc exam will have a couple questions they throw in here and there that are questions for the like just recognizing the definition. Okay, so, and I will ask you to memorize those in class. We'll have little note cards and I'll catch you at the door and everything once I can be back there. All right, so get that in your notes if you haven't already, and make it make sense to you. So don't move on until that makes sense to you. All right, and then the horizontal asymptote, kind of the same thing. So if we have some function that has a horizontal asymptote, let's see this one right here, and I create some sort of function or something, it doesn't matter. And we want the limit definition. So we're going to start with, okay, the limit as x approaches. Now, in this case, if we're looking at a horizontal asymptote, it's easy to see, I think, hopefully, that our x values are going to approach infinity. So my x values are going to be getting larger, and it could be positive infinity or negative infinity of that function. Okay, so what's happening as my x values approach infinity? What should it equal? Okay, so in order to have a horizontal asymptote, so you think about that. Okay, so in this case, it would have to equal some number b. Okay, so we'll just say that this is our y value of b. And so in this situation, again, it should make sense. So stop, make it make sense to you. And you can pause the video if you want to. And then when you're ready to move on, the last thing we need to cover, because it kind of pulls all this together, is in behavior models. And this is something from pre-calc, so I'm just going to kind of walk through the three situations, and then we'll talk about what that has to do with limits. Okay, so the end behavior model here, so that all that means is that you can get a good idea of what that graph is going to do just by using the largest part of the numerator, meaning the highest degree term, and same thing with the denominator, and just look at those and divide that, simplify that to get what your model, the model of your graph is going to do. So in this case, I would have, let's say it would just be 2/3 x cubed. So this particular rational function with all that mess in it is going to be nothing more than a cubic function by the time you plug in all your x values. So that's what we're doing, is we're just simplifying it down so that we can look at it and be able to kind of get more of an idea of the graph. The reason we're doing that is because we're going to find horizontal asymptotes using these, okay, which is very, very popular in calculus. So let me just go through the three of these and I'll show you what that means for horizontal asymptotes. So the next one, then obviously if they are, oh shoot, I messed this up. Okay, that's okay. I have two of the same ones. So for B, let me change this to 5x to the 5th on the bottom. Okay, so then this would be 2x to the 3rd over 5x to the 5th. So notice in part A, I had the largest on top and the smallest number on the bottom. Now I'm flip-flopping that, so I have the smallest number on top, largest number on the bottom. So if I reduce that, it would be 2 over 5x squared. Okay, which means I have some function that has an asymptote in it at 0, right? So it's some variation of this function with a 1 over x, okay? So then the last one is when they're the same. So 3x to the 4th, and it doesn't have to be 3. Let me make this a 6x to the 4th, just so you don't get the wrong idea. So this would be 3x to the 4th over 6x to the 4th. And if I reduce that, I would have 1/2. So that's just going to be a constant. Okay, so that means that your end behavior is just going to be a constant in that case. Okay, so then what does that was a reminder of your pre-calc information. So now what does that mean for calculus? What do we need to be able to do with this? And we want to be able to find our limits. I'm sorry, we want to find horizontal asymptotes. This is not the best way to write here. So horizontal asymptotes, if I put a limit as x approaches infinity or negative infinity of, let's say, something like this first function, 2x to the 5th over 3x squared. So now, of course, I would give you the whole function. You would have to pull out the end behavior model like this. Okay, so then let's see what's going to happen here. So we'd have the limit as x approaches infinity of my end behavior model is going to be 2/3 x to the 3rd. So what does that mean? Well, if I have a cubic function, think about what my cubic function looks like. A cubic function looks like this, right? So as I approach positive infinity, wouldn't it be true that my answer would be infinity? No, of course, because I have a smooth and continuous function. When that exponent on the top is the largest, that means I'm always going to be left with a polynomial. So you're always going to be going to infinity or negative infinity. Now here's another situation with the same question, and you kind of have to know your polynomial to answer these. But what if I asked you for the limit as x approaches negative infinity? Negative infinity. Now you've got to consider the fact that of this cubic function, when I approach negative infinity, my values are actually getting smaller to negative infinity. So that's the only thing about that one is it's not always infinity. It's not always negative infinity. It depends on the function. So like if I had one, here's another example. Let's say I gave you one that was like the limit as x approaches infinity of my end behavior on top was, let's say, you ended up with a 3x squared over 2. Now that's obviously a polynomial. I'm sorry, not a polynomial, a parabola. And so in that case, whether I approach positive or negative infinity, it wouldn't matter. My answer would be infinity. So again, it just depends on the idea of the function itself. All right, let's see. So the next one, now let's say I take this part B, and now I have the largest on the bottom. So my question says, find the horizontal asymptote. So you have to test positive and negative infinity if you're asked for that. And let's say I have this 2x to the 3rd over 5x to the 5th. So that makes this 2 over 5x to the 2nd. All right. Then think about what's always going to happen here. No matter how many ways I work this, if I have a 0, my function will be undefined, right? So if my denominator is going to be undefined at 0, then that means 0 can never be an answer. So my horizontal asymptote would have to be y equals 0, right? If you're asked for horizontal asymptotes. So actually, let me back up then. So let me go back to part A then, because we didn't actually answer the horizontal asymptote part of that. I hope you understand that the limit would go to infinity or negative infinity. The horizontal asymptote part of that, though, would be none. So if you were only asked for the horizontal asymptote, you would say, well, there's not one because I have a polynomial. I don't have a horizontal asymptote with a polynomial. Okay, so hopefully that makes sense to you. Let's see. And then the bottom part here, we have, oh, okay, never mind. So we did that part. So the horizontal asymptote would be y equals 0 for the second when you have a larger degree in the denominator. Now the last one's the easiest, and anytime it simplifies to a constant number, then we already know that the limit is x approaching infinity of 1/2 is just 1/2. So there's no secrets there. All right. So I hope that you all were able to grab some notes from that. Please feel free to stop, back up, watch whatever you need. Again, as far as the quizzes, we will go over those tomorrow, and I will make sure that you're able to, no, I'm sorry, not tomorrow. We'll probably have to go over them on Tuesday, but I will get your grades in here shortly. Okay, and then if I have time, maybe I'll even make a video for you tomorrow to watch to kind of like go over the quiz a little bit, but we'll see. Actually, no, I have people who haven't taken it yet, so I can't do that. I'm sorry. I was thinking too early. But what we will do is make sure and go over them. I'll get your grades in. We'll go over them on Tuesday when hopefully I can be back. Okay. And I don't know if you got to see. Hey, girl. There they are. I just remembered. I don't know if you got to see them in the beginning of the video. So anyway, I hope to see you guys soon and have a great day.